This y is our observation and x is our suppose initial something. So if you put x, y and whatever dimension you give, if you put here 1, then it's a first order polynomial fitting. Similarly 2, it will be with the quadratic. So it's a very simple fitting of the function in math. Then one more is there. Based on the cubic spline. So again, actually some direct commands are there that I use to fit the first order, second order polynomials.
What is the results you find? How change the order?
Yes, as we increase the order of the polynomial, it goes nearer to our analysis value. Means whatever the y value is given, it goes towards the y. Yes, definitely.
Do you know there's a fundamental theorem in mathematics? If you have n plus 1 points in a two-dimensional plane, you can fit an nth degree polynomial precisely that way. So the maximum degree of the polynomial that can fit, that you are given n points, is n minus 1. But then, so the question comes in: do you want to fit all the points precisely, or do you want to have a least square fit? So that's what's called overfitting. If you fit the model overlay, it may explain the data very well, but it may or may not do very well in its top line. You want to have a little bit of a leverage for the model to relax itself. So lower order models are slightly better than higher order models, though higher order models will fit the data much better. So in model building, which model is better? What are the criteria for choice of models? So in empirical analysis, this is one of the fundamental questions. There are lots of norms to be able to evaluate the fitness of the model. What is the general guiding principle? The model must be lean and mean. There's a principle called Occam's razor principle. That principle essentially says, don't make the model too complicated. Too complicated model may not help you to be able to extend. The model with a little bit of freedom should be able to adjust itself when it comes to and that's exactly what you said in this one.
Is there any other group that wants to comment on this or contribute?
Number you will get, according to that you will get yes. Okay, x I assume as our years. Something years are given in our CO2, and y is our values. And then in this I use some scaling because it starts from something 959 something to so on. So I use some scaling and make this smaller value. Similarly, I use some scaling here. It is of the order of 331 something. Then again I use scaling so that the computation will be slightly easier.
But if you do this polyfit, the sum like in 7 degree, the some coefficients are very big and some are very small.
But once if you use this type of scaling, then it is slightly of the same order.
You take arbitrary scaling, or how do you decide scaling? How do you decide the scaling?
Okay. Actually, these are some scaling I put on the basis of the mean of this data. Suppose if I have a data start from year 1957 to some different year, so I take the mean of that, and that year I take as a mean. Then from that I find the different value which is our something. Suppose
Okay,
this is our mean, then x minus mean of that. Same thing I subtract with this y minus y.
X minus mu by sigma.
Yes, but once you go in the power of x to the power 7, then definitely it will be very high.
That's a clear number, right? Yes. It will always be 4 digits. You can't go more than 4 digits.
You can try directly also.
Even that number, CO2 level won't go more than say 3,000 or more than that. Never.
380.
Yeah. So that's all.
Yeah, you can use directly also, but it's
What is the
one of
value did you get for 20 first order fit?
first one. Oh, that I did.
You have to predict, right? After fitting the curve, you need to predict the
Prediction. I can get only the y values and y corrected values. One dimensional polynomial, two dimensional polynomial.
And we can calculate the variance.
How will you know? How will you know what is the error and all this?
Okay, that for that you can find the. There are some other options. Suppose you find the y due and y is there, then you can find the relative error, percentage error, that type of calculation you can do. Suppose you have a y due is there, y observation you already have, CO2 levels. Then from these two you can find the how much error is there.